Welcome to this segment of the Math Coach. Today, we're going to take an in-depth look at mid-chapter review questions from unit number 4, exponential functions. But before we do that, I'd like to give a big shout out to my peeps at Explain Everything, who have provided regular people with such an amazing app. And now, let's get started. Let's take a look at page 239, number 9, and correct some of these problems. If you need help with any of these exponent rules, please refer to my lessons from chapter 4. So we'll start off with number 9b. Remember that exponent rules can only be applied to bases that are the same. Now luckily, if you take a look at every single one of these bases, the bases are n. You have n to the exponent of -4, you have n to the exponent -6, and then you have this situation happening at the bottom as well. Now, remember to take this one thing at a time. At the top, I'm actually going to do the multiplication rule. Remember, when you're multiplying two bases that are the same, you keep the base the same and you add the exponents. -4 plus -6, so obviously I'm doing -4 plus -6 in my head, and -4 plus -6 is actually -10. Notice that I did not change this n to the -4. I didn't change that negative exponent to 1. So I didn't take this and change it to 1 over n to the +4. I understand that that's what it's equal to, but I'm not going to do that in this situation. It's only the final answer that cannot be written with negative exponents. So if the final answer has a negative exponent, then and only then will I change the final answer to something like that. But over here now I have, this is a power of a power rule. This is n to the -2 all to the exponent 7. Okay, so n to the -2 all to the exponent 7. A power of a power, you keep the base as n and you multiply the exponents together. -2 times 7 is -14. So that's what I have on the bottom. And now I can divide these two things. So dividing these two things, again, with the division rule, if you have two bases that are the same, you're going to keep the base the same, and you're going to subtract the exponents. Now remember, I'm subtracting the exponents in order. It's -10 minus -14. So be careful there, because -10 minus -14 is actually -10 plus 14. And -10 plus 14 is actually 4. So the final answer is n to the power of 4. This is a positive exponent, so I don't have to change anything about this. This is the final answer. Let's move on to 9c, where you have this big situation here. Now, just understand here that I know that all my bases are y's here. Some of you may want to take care of this -2. I wouldn't do that. You can do that. There are ways of going about doing this thing in that way. But what I'm going to focus on is actually all of the stuff inside of the bracket first. That's what I'm going to do first. Simplify all of the stuff inside of the bracket first. And if I do that, what I'm going to get, I will leave all of this to the -2. I will take care of the top first. See this top over here, this is y to the power of 2 to the power of 6. That's a power of a power. The rule is keep the base as y, multiply the exponents, and 2 times 6 would be 12. Now the bottom stays as y to the power of 9. Continuing this, now I'm going to also focus on what's inside again, because what's inside again is a division rule. You have y to the 12 divided by y to the 9. So if we focus on that and disregard this for right now, leave this to the -2, y to the 12 divided by y to the 9, the rule is keep the exponent the same, and you're going to subtract the exponents. 12 minus 9 is 3. Continuing this up here, now I'm left with a power of a power. I have y to the 3 all to the -2. That's a power of a power. And so the rule is keep the base as y and multiply the exponents. 3 times negative 2 is negative 6. This is almost my final answer. I can never leave my final answer with a negative exponent. So what does this mean? We know from the negative exponent rules, this just means 1 over y to the positive 6. So that's one of my exponent rules that I spoke about. Make sure you look over the exponent rules if that's confusing. So if we look at 9D, 9D involves letters and numbers. Just be careful here. When we are doing this one, I'm going to take care of the stuff at the top first because I have all of this, all of it, to the exponent 3. So just remember that exponent 3 applies to everything in here. It applies to the negative 2, and it also applies to the x to the power of 5. All of this is cubed. So if we know how to cube those things, really what that means is negative 2, that cubed, and also the x to the power of 5 cubed. Now normally I would skip this step right here. I wouldn't have written that, but I'm writing that out so that you understand what to the power of 3 means for both of those items. So don't forget about the 2. Now on the bottom, that to the power of 10 only applies to the x because it's only attached to the x right there. It isn't attached to the 8. Continuing this, at the top I have negative 2 to the power of 3. Well, negative 2 to the power of 3 is negative 2 times another negative 2 times another negative 2, which is actually negative 8. And then we have x to the power of 5 to the power of 3. That's just the power of the power rule. The rule is keep the base as x and multiply the exponents. 5 times 3 would be 15. On the bottom, I still have 8x to the power of 10. Continuing this, now I can do the division between both numbers and the variables as well. So negative 8, first off, I'll do negative 8 divided by 8. Okay, so negative 8 divided by 8 is negative 1. Then I have x to the power of 15 divided by x to the power of 10. The rule is for division, keep the base the same, x, and 15 minus 10 is 5. So this is the final answer. This is just equal to, I don't need to write the 1 there, this is just equal to negative x to the power of 5. This is fine. It's okay for the negative to be out in front here. What you can't have is the exponent being negative. And the exponent isn't negative, so this is the final answer. So this 9e can get a little confusing. So if we look at this, look closely at this, it's this entire bracket to the power of negative 3. So I'm going to take care of that first. I have to take care of a power first. This has to be taken care of. So please don't go multiply this stuff by that stuff. That you cannot do first. I'm going to take care of this power of a power first. Just remember what that means. That negative 3 applies to both of these things inside of here. This is 3 times a squared. So this is actually 3 to the negative 3. And it also is a squared also to the negative 3. Again, sometimes most people will skip this step. They won't write that. I like to write that just because some people forget about this 3 to the power of negative 3. They don't apply it to the 3. So we got to remember to apply it to the 3. So this is why I'm writing it out the long way. So that's that one there. Now, similarly, it's 9 times a to the power of 1 all squared. So I have to square both of those things. That's all multiplication in there. So you have to incorporate the 9 has to be squared, and also the a to the negative 1 also has to be squared. Continuing this, 3 to the power of negative 3. Well, 3 to the power of negative 3, most of us understand from exponent rules, that means 1 over 3 cubed. Okay, so that's what that means. Then a to the power of 2 to the power of 3, that's a multiplication, that's power of a power, so we multiply the exponents. 2 times negative 3 is negative 6. So that's that. Then I have 9 squared. 9 squared we know is 81. And then I have a to the power of 1 to the power of 2. That's also a power of a power. And we know a power of a power, you keep the base as a and you multiply the two exponents. If you multiply those two exponents, you get negative 2. Continuing this, I'll write the numbers first. So that 81, I'll write it over here. This is 81 over, now 3 cubed is 3 times 3 times 3, which is 27. And then I will multiply those two together. And the exponent rule is keep the base the same, keep the base as a, and add the exponents, right? So negative 6 plus negative 2 is equal to negative 8. So that's what I'll write, a to the negative 8. Continuing this, if I continue this, 81 over 27, I can actually reduce that. Both top and bottom are divisible by 27. So 81 divided by 27 is 3. And 27 divided by 27 is just 1. So obviously you could do 81 divided by 27, which is just 3. So, and then I have a to the negative 8. Okay, so that's almost the final answer. We can't leave this as the final answer because we can never have an exponent with a negative number. So the 3 is okay at the top of this fraction, but the a, I can write this as 1 over a to the positive 8. And notice I've already written this way. Really, some people like to go the extra step and say, okay, I can rewrite the a to the negative 8 as 1 over a to the positive 8, and then you just get that there. I just did that in one shot. So that's the final answer, 3 over a to the power of 8. Okay, the last one from question 9, number 9F, looks a little complicated. Just make sure that we do not multiply this times this first. We're going to take care of all the powers of powers first. So those are all the things I'm going to take care of first. For instance, we know that all of this is to the power of 5. So that 5 applies to here and here. And we also know that all of this is to the power of 4. So that 4 applies to this and this. So we're going to take care of those two powers of powers first. So I'm going to leave this as 4r to the power of negative 6. And remember that power of negative 6 only applies to the r. It doesn't apply to the 4. It's not attached to the 4. And over here, that 5 applies to both of these things. So this is negative 2 to the power of 5. And it's also r squared to the power of 5. Okay? And then on the bottom, that 4 applies to the negative 2. So that's negative 2 all to the power of 4. And that's also r to the power of 4. Because that r doesn't have any other number attached to it. Continuing this is 4r to the power of 6. And in this bracket, negative 2 to the power of 5 is negative 2 times negative 2 times negative 2 times negative 2 times negative 2. It's negative 32. And then r squared to the power of 5, that's a power of a power. So leave the base the same, multiply the exponents, is to the power of 10. And on the bottom, I have negative 2 to the power of 4. That's negative 2 times itself 4 times, which is positive 16. And then you have r to the power of 4. So I took care of all my powers of powers first. Continuing this, I'm going to continue this up here because we're running out of room. Continuing this, now I will do the multiplication on the top. So the bottom, I will leave as 16r to the power of 4. On the top, I'm going to multiply this all out. Remember, this is all multiplication. This is 4 times r to the 6 times this times this. There's no additions in between or anything like that. So I'm going to multiply the 4 times negative 32. And that gives me negative 128, I believe. And then r to the 6 times r to the 10. So r to the 6 times r to the 10. The rule is keep the base as r. and add the exponents. 6 plus 10 is 16. Continuing this, now I'm going to do the division rule. And so dividing these two things by each other, when I do 128, negative 128 divided by 16 is negative 8, I believe. Yes, 8. And r to the power of 16 divided by r to the power of 4, the rule is keep the base the same and subtract the exponents. So that's 16 minus 4 is 12. So this would be my final answer. This is good. Even though this is negative out in front, that's okay. All that matters is that the exponent is a positive exponent. And so this is my final answer there.
We interrupt our program to bring you this important message.
You know, I sit here and think, well, if I wasn't playing football, what would I be doing?
Right.
35! 52! 50.
Let's take a look on page 239, number 10A with decimals. Now, the first thing we're going to do before we start doing any division rules is we're going to first convert all of these decimal numbers into fractions. Now, obviously, the easier ones, which is 0.5, we can convert that very easy. That's x to the power of a half. And over here we have y to the power of 1.8. So how do you make 1.8 a fraction? Well, 1.8 is a fraction. It's 1.8 over 1. If you have a hard time making 1.8 a fraction, all you got to do is a fraction cannot have any decimal in it. So in order to get rid of that decimal, you can multiply both top and bottom by 10, which would give you 18 over 10, and then you could reduce 18 over 10. Both top and bottom are divisible by 2, so 18 over 10 is the same as 9 over 5. And of course, if you do 9 divided by 5, it actually is 1.8. So this is 9 over 5. The next one over here, x to the power of 0.3. 0.3 is not a third. Remember, 0.3 is 0.3 over 1. If you want to convert this into decimals or into fractions, it is a fraction, but you cannot have a decimal, so I will get rid of the decimal place by multiplying by 10. So if I do the same thing both top and bottom, this is the same as 3 over 10. That is the proper format of that decimal. Then if you look at 2.5, I mean, some of us know 2.5 is 5 halves, but $2.50 is half of $5, so it's 5 halves. However, if you didn't know that, we can convert 2.5 into a fraction. So if I do 2.5, it's over 1. Again, to get rid of this decimal, I will multiply both top and bottom by 10. And if I do that, I actually get 25 over 10. I can reduce this number because both top and bottom are divisible by 5. So this is the same as 5 halves. So this is the same as y to the power of 5 halves. I'm going to erase all this stuff over here. And now continuing this, I can actually do the division between these two things right here, because that is a division between two bases that are the same. So to divide, I would write the base as x, and I would subtract the exponents. So I'm going to have to take the first exponent, which is a half, and subtract the second exponent, which is 3 over 10. Now, in order to subtract exponents, you can either use subtract fractions, you can either use the fraction button on your calculator, if you know how to use that. And I'll put a video on that later. However, you should be able to deal with fractions because we can make both of these tenths. That's already 3/10, but we could make this half into tenths because if I multiplied the bottom of this by 5, obviously I would have to do the same exact same thing to the top because whatever you do to the bottom, you have to do to the top. So this is the same as 5 over 10. 5 over 10 is still a half. And so now you could do 5/10 minus 3/10, and that is the same as 2/10. And you could reduce 2/10 to be a fifth. So this x to the power of a half divided by x to the power of 3/10 is the same as x to the power of 1/5. Okay, and then we could do the exact same things for the y's. We have y to the power of 9/5 divided by y to the power of 5/2. So again, the division rule, keep the base the same. And then you have to subtract the exponents in order. So I'm going to take 9/5 and I'm going to subtract 5/2. Now in order to subtract these two, I'm going to make a common denominator. And of course the common denominator will be 10. And how did I make the first one a 10? Well, I multiplied by 2, so I have to do the same to the top. So 9/5 is the same thing as 18/10. And 5/2, how did I make this a 10? I multiplied by 5, so I must do the same to the top, multiply by 5 as well. And so 5 over 2 is the same as 25 over 10. And so 18/10 minus 25/10 leaves me with negative 7/10. And I can't reduce that. So this would leave me with y to the power of negative 7 over 10. Continuing this, I'm going to rewrite this properly because the final answer cannot be written with negative exponents. So x to the power of the fifth is okay at the top. But this y to the negative 7/10 is written properly by putting this as 1 over y to the positive 7/10. Okay. Another way of rewriting that, because sometimes the back of the book wouldn't want fractions as your as your final answer for the exponent. So remember what that means. That actually means the fifth root of x to the power of 1, because there's a 1 at the top. But I'm not going to write that one. That's just an obvious thing. And on the bottom, of course, this bottom here, that is the 10th root of y. So this is the 10th root of y to the power of 7. Now the 7 can either go right there, or you could actually write the 7 inside like this. For me, well, it all depends on the question, but I prefer to write it like this. So this would be my final answer. Now, some people have actually asked me, sir, can't I just do this immediately for this question? Can't I just, because those are both the same base, can I not just keep this as the same base and subtract the exponents? 0.5 minus 0.3 is just 0.2. And then can't I do the same with the y's? The y's, y to the power of 1.8 divided by y to the power of 2.5. I can keep the base the same, like the rule states, subtract the two exponents, and if I have 1.8 minus 2.5, I get negative 0.7. I mean, is this acceptable? Yes, it is acceptable. But you have to understand that no matter what, the final answer cannot be written with decimals. So what you're going to have to do is you're going to have to convert the decimals now regardless. Maybe this is easier for you so that you don't have to subtract fractions. So, of course, x to the power 0.2. So 0.2 I know is a fifth, but if you didn't know that, it's 0.2 over 1. Okay, And if you multiply both top and bottom by 10 so that you can get rid of the decimal, you're going to get 2 over 10. And 2 over 10, if you divide both top and bottom by 2, is the same as a fifth. So this is x to the power of a fifth. And likewise, we're going to change the exponent 0.7. Now 0.7 we can write as a fraction also. We know that 0.7 is the same as 0.7 over 1. And of course, to get rid of that decimal, if we multiply both top and bottom by 10, we're going to end up with 7 over 10, and you can't reduce that. So you end up with negative 7 over 10, which is exactly what we were doing before. And of course, you can rewrite this as x to the power of a fifth all over y to the power of positive 7/10, because that's what the negative exponent means. Write it on the bottom with the positive exponent. And you can continue on the problem just like we did. We're taking a look at 10b. So 10b, please be very careful. I would not do this. What you may be thinking is do this division right here, do this division right here. And that is not what you should be doing right now. What you should be focused is on the power of a power. This power applies to both of those things in there. So that's what I'm going to take care of first. That is this m to the power of negative a half. And this is n cubed to the power of negative a half. That negative a half applies to both things. So then I end up with this on the bottom still. And of course, I mean, some people can skip this step right here. I mean, some people may not write that right there. They do. They recognize that this is 3 n to the power of 3 to the power of negative half, and they already multiply the 3 by the negative half, and that's okay. However, I'm going to do one step at a time. So this is m to the power of negative a half. And now this is a power of a power right there. So I am going to n to the power of 3 to the power of negative a half. You multiply those two exponents. 3 times negative a half is negative 3 halves. And on the bottom, I'm going to get m to the power of a half, n to the power of negative 5 halves. You just have to be very careful when you're doing these things. Then, when I go to actually divide these things, now I can actually divide this right here. There's no more powers of powers, so I can divide that. Of course, when I'm dividing stuff with the same base, I keep the base the same and I subtract the exponents. So be careful. On your calculator, you're going to just do a half. You have a fraction button, and you're going to subtract negative a half minus a half on the bottom. Negative a half minus another half is negative 2 halves. Okay, and negative 2 halves is the same as negative 1. So that's all I'm going to write here, m to the negative 1. Then I'm going to do the same thing with the ends here because there's no powers of powers anymore. So again, the rule states keep the base the same for division, and you're going to subtract those two fractions. So you're going to do negative 3 halves minus, be careful, it's negative 3 halves minus, and then this number, negative 5 halves. So negative 3 halves minus negative 5 halves. Well, that's the same as saying negative 3 halves, a minus and a minus become a plus, plus 5 halves. I mean, it's great that the denominators are the same because now we can add these two things together. And negative 3 halves plus 5 halves is positive 2 halves, which is the same as positive 1. So I'm going to write that as positive 1. And of course, we're not going to leave the final answer like this because we cannot leave m to the negative 1. This is a problem right here. So the n is okay. N is to the positive 1. Now I'm not going to write that 1. There's no need to do that. But I'm going to write this m to the negative 1 as the m on the bottom to the positive 1. Right? So I'm also not going to write the 1 down there. Remember that m to the negative 1 is the same as writing 1 over m to the positive 1. Okay, so all I did was write that m on the bottom here to the positive 1. And that's your final answer. Now we're going to look at 10E, because 10E could be a little confusing if you think about it wrong. Please refrain from trying to do the 81 divided by 9 right now and the p to the power of 8 divided by p to the power of 4, because you actually can't do that. You have to take care of powers first. You may say, but sir, there's no powers of powers. Actually, you're wrong in that respect, because this 81 p to the power of 8, remember what this actually means. The fourth root is the same as writing to the power of a quarter. We know that from looking at that lesson. And so this is 81p to the power of 8 all to the power of a quarter. Similarly, on the bottom, remember what this means. Remember, this is square root. Now, they're not going to write the 2 there. That's an automatic assumption that's a 2 there. So I'm not going to write it there. But remember that this is 9p to the power of 4, and that square root actually means to the power of 1/2. So you must take care of these powers of powers first. This quarter applies to both things in there. So you have to be careful, because on the top you actually have 81 to the power of a quarter. You also have p to the power of 8 all to the power of a quarter. And on the bottom, this 1/2 applies also to both things. So you got to be careful. This is 9 to the power of 1/2, and this is p to the power of 4, that also to the power of 1/2. Continuing this, let's actually simplify this. 81 to the power of a quarter. Now I'm actually gonna do that on my calculator, because 81 to the power of a quarter is the same as the fourth root of 81. So I'm gonna show my teacher that I understand what that means. Okay, and then just remember this power of a power that's occurring right here. This is p to the power of 8 to the power of a quarter, and we know that powers of powers, we leave the base as p and we multiply the exponents. 8 times a quarter is 8 quarters. I mean, some of you would probably skip this step of 8 quarters and just write a 2 up there, but I'm going to show my work. And then I'm going to take care of the 9 to the power of 1/2. So 9 to the power of 1/2, what does that mean? It means the square root of 9. And then I'm also going to take care of this power of a power over here. This is p to the power of 4 all to the power of 1/2. So the rule is keep the base as p, multiply the exponents. 4 times 1/2 is 4/2. Continuing the scenario, the fourth root of 81 is 3, because 3 times 3 times 3 times 3, so 3 times itself 4 times is 81. And then I have p to the power of 8 divided by 4 is 2, all over. Now the square root of 9 is 3, because 3 times itself is 9. And then this is p to the power of, and 4 divided by 2 is 2. I mean, most of us can just see that this is 1. 3p squared divided by itself has to be 1. However, if you didn't see that, 3 divided by 3 is 1. P squared, just looking at our rules, p squared divided by p squared, the rule is keep the base the same and subtract the exponents. 2 minus 2 is 0. And we know that anything to the power of 0 is 1. So you have 1 times 1, which is 1. I mean, it's pretty recognizable, this step right here. 3p squared divided by itself. Anything divided by itself is 1. So, I mean, I'm okay with you jumping right up to there. But that's your final answer. So 10F is very much like the last one, except there's another little trick. So if I look at all this stuff, I realize that this 6th root means to the power of a 6. This 4th root means to the power of a quarter. However, inside of this, this situation right here, I'm going to take care of that stuff first. because I see within this sixth root, this over here has a power of a power. This too applies to both things in here. So I don't want people to get confused. So I'm going to take care of that first, because that's 8 squared, right? And that's also x to the power of 6 all squared. And then on the bottom, this stays the exact same. So there's actually an extra step, because inside of this top, the numerator, there was a power of a power within the square root or the sixth root. Now continuing this, I'm going to do 8 squared, which is 64, and x to the power of 6 to the power of 2, that's the same as x to the power of 12, it's a power of a power. So this is really the simplified version of that question. Now I can start. Now I can start by writing what the sixth root actually means. Okay, and so the sixth root, remember, if I'm taking the sixth root of this whole thing, you're taking the sixth root of both things. Now, other people have asked me, sir, can I not split this up to do the sixth root of 64 like this, and the sixth root of x to the power of 12? Can I not split it up like that? And the answer is yes, you can split it up like that. And can't I, do the fourth root of 625? Because I know I'm going to have to do the fourth root of that. And, instead of writing the fourth root of x to the power of 8, can't I just right away write x to the power of 8 to the power of a quarter, because that means the fourth root? I mean, yes, if you like to do that right away, do that right away. I mean, I'm comfortable with doing that, but it's all on your comfort level. So I will just write the fourth root so that we're doing all the same stuff here. Now the sixth root of 64, I believe, is 2, because 2 times itself 6 times is 64. Then I will write now, this is x to the power of 12, and the sixth root, remember what sixth root means. Sixth root means to the power of the sixth. Okay, and then over here, the fourth root of 625, I believe is 5, because 5 times 5 times 5 times 5 is 625. And then I'm going to rewrite this as x to the power of 8, all to the power of a quarter. Okay, and then continuing this is 2. Now, I can multiply these two things. This is x to the power of 12 to the power of a sixth. And I could do 12 times a sixth. Now I'm going to skip a step here. I'm going to keep x as the base. 12 times a sixth is 12 sixths. 12 divided by 6 is 2, right? 12 sixths is 2. And then on the bottom, I'm going to have 5. And then I'm also going to do this multiplication, 8 times a quarter, right? So that I have the base is the same. That's a power of a power. 8 times a quarter is 2, or 8 quarters, which is 2. Continuing this, now I'm left with the 2 at the top and the 5 on the bottom, but I'm going to do this division right over here, this x squared divided by x squared. And we know that that's just x to the power of 0, because 2 minus 2, right? Or we could have just said, okay, let me just cancel this x squared over here with that x squared over there, and that's just 1. So those are gone, and you're just left with 2 over 5. But, if you want to look at showing every single step, this is 2 over 5 times, obviously, 1, because x to the power of 0 is just 1. There have been a lot of people asking me about question 12, so I might as well do the hardest one from question 12. So obviously, this scenario here, you want to try to always use exponent rules, okay? And right now, if you look at the first bracket, there's nothing to do here. This is x to the power of all this stuff, by the way. Okay? But then, if you look at the second bracket has a power of a power, because it's all of this stuff in here to the power of m plus n. Now, how am I going to go about doing this question so that after I'm done doing all of this stuff, I can then multiply with that stuff? Well, I see a big problem already, because I see that the x is over here on the bottom of the fraction. And if I wanted to multiply that later on with that, I mean, I'm going to have to make sure that this thing is not a fraction. That's what I'm going to make sure of. How do I do that? Well, there's one little simple step that you have to do here. So I'm going to leave this as x to the power of 4n minus m. It's actually probably better if we write the brackets at the top there. And in here, there's a trick. Okay, I'm going to leave this as m plus n, but I can rewrite this thing. If you really want to get crafty, I can rewrite that thing as x to the power of negative 3. If you think about it, that is the exact same as what's highlighted in red there. Now, all these x's are at the top. There are no fractions. Now I can apply some of these exponent rules. So when I look at this, I got x to the power of 4n minus m, okay? And over here, I'm going to do the power of a power. This is x to the power of 3, negative 3, all to the power of that. So you got to be careful here, okay? You got to be careful because those should technically also be in brackets. This is x to the power of negative 3, all to the power of that. So when you go to multiply that, you keep the base the same. When you're doing a power of a power, you keep the base the same and you multiply these two exponents. So this is negative 3 times both of those things, which is negative 3m minus 3n. Now continuing this, I can continue this because I know how to multiply two bases that are the same. Both of these things here, this in this bracket and this in this bracket, both of those things have the same base. They both have x as the base, okay? And so if I was to multiply two things with the same base, I'm going to keep the base the same and I'm going to add the exponents. I'm going to add them. So you could take them off to the side and add them, or you can write them right as the exponent and add them. That's what I'll do. 4n minus m plus, so 4n minus n plus negative 3m minus 3n. I mean, some of you won't like this at all. I mean, you don't like to see this huge thing over here as your exponent. And granted, if you do not like that, okay, I know that I said that I was going to do it like that. If you do not like that, you could take this off to the side and add this exponent with this exponent. So if I did that off to the side, maybe it's a little easier. 4n minus m, I'm going to add this with this, negative 3m minus 3n. Okay, so clearing the brackets here, I have 4n minus m. The positive sign here will make this negative 3m minus 3n. Adding the like terms, 4n minus 3n is positive n, and negative m minus another 3m is negative 4m. So this is x to the power of n minus 4m. This is your final answer. Well, my time is almost up. I'd like to give another quick shout out to the Explain Everything crew. Hopefully, this video was helpful for you. I'm the math coach saying see you next time, and thanks for watching.